So we've talked about what your graphs for the sine function look like and for the cosine function. Now, when we first met, we also talked about that there are other functions out there, other trigonometric functions out there. We talked about the cosecant function, secant function, tangent, and cotangent. So what we're going to do in this section is we're going to look at the graphs of those other functions. The best news is you're not required to graph them with transformations or graph them at all. All I'm doing is showing you what the graphs look like so you can be able to recognize them. And how we're going to start this is we're going to just briefly go over what that graph of the sine function looks like. And hopefully you're feeling really comfortable with this at this point. So I have a chart here that I'm going to fill out. I have included the unit circle to just refresh us. But again, I really hope we're starting to memorize that and we have that locked in our memory. I'm going to choose key points to make my graphing a lot easier. So the angles I'm going to choose are 0, pi over 2, pi, 3 pi over 2. And here's our unit circle for reference. When I put in 0, my sine function will spit out 0. When I put in pi over 2, my sine function spits out 1. When I put in pi, spits out 0. And when I put at 3 pi over 2, spits out -1. And if you completed that revolution, you'd be here again, and again, you'd spit out 0. Because remember, sine is periodic, so it will start to repeat itself. So these are the coordinates that we'll plot on our coordinate plane. So our input 0, our output 0. Inputs pi over 2, outputs 1. Inputs pi, outputs 0. Inputs 3 pi over 2, and outputs -1. All right, I'm going to go down here to our graph that's provided and plot those points. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1. And then remember, if you hit 2 pi, you'll hit 0 again. Now, we talked about how sine is an odd function. So I'm hoping at this point this feels comfortable to you that I can just go ahead and come up with the other side without doing any work. And so I'm going to give myself, make sure these are rounded edges, make sure they go through the points. I say that for myself with this iPad. Okay, so this is, and really make sure too that we always label our graphs. All right, so that sine function, I'm hoping you feel good about. I'm going to make this look a little bit better right down here, or try to at least. Well, when we first met each other, we talked about how sine has a reciprocal function, which is the cosecant function. Now, remember, the reciprocal function means, just to refresh our memory, cosecant is the same as saying 1 over sine. So remember, we went ahead and we found the reciprocal. So when sine of theta equals opposite over hypotenuse, the cosecant theta equaled hypotenuse over opposite. So what we're going to do here is our angles, our inputs are going to stay the same. So I'm still going to put 0, pi over 2 in, pi, and 3 pi over 2. The difference is our output will be the reciprocal of what sine had. So if I went ahead and remember that's 0 over 1. So maybe let me just change that just to refresh our memory. I'm going to write these all as fractions. So this is 0 over 1, this is 1 over 1, 0 over 1, and this was -1 over 1, right? Every number is over 1. Now, if you went ahead and you flipped that 0 over 1, then you're going to have 1 over 0, which hopefully you remember is undefined. You cannot divide by 0. Well, since that's undefined, I can't have a coordinate. But if I flip the next one, 1 over 1, well, I just get 1 over 1, which is just 1. If I flip that next one, I get 1 over 0, which is undefined. And then the next one would be 1 over -1, which would give me -1. So this does give me a nice coordinate. That's pi over 2, 1. And this one would be 3 pi over 2, -1. Well, when we have undefined, on our graph, I'm going to choose a different color for our cosecant. It becomes an asymptote. We have to let the reader know it cannot be this value. It cannot be this value for our cosecant graph. Can't be this. So everywhere I'm hitting that x-axis where my output is 0, I'm going to have an asymptote. Well, we found out when we put pi over 2 in, it still spit out 1. So this is a coordinate on my graph. And then we also found out with our chart that this is also a coordinate on my graph. We can do that other side. Just think about if you were to flip -1, because that's your output, you would still get -1. So that's still a coordinate. And if you're going to find the reciprocal of 1, flip it, it would also be 1, right? Because 1 over 1 flipped is just 1 over 1. So all those pink points are coordinates on my cosecant graph. Well, what happens here is think about if you were to flip this output, okay? I don't know exactly what that is, but it's a pretty tiny number. And if you went ahead and you flipped a tiny number, so a tiny number over 1, now it becomes 1 over a tiny number. What happens is that it becomes really, really large. And so what your cosecant graph takes a look, or starts to look like, is these little parabolas. And then down here, it will be all here. And then here. So they like bounce off that sine wave. And so that makes a little bit more sense. I'm going to try to explain a little bit more. If you take all of these, just think about it. You're taking all of those y values and you're flipping them. That's going to become all these outputs. If you take all these y values and you flip them, it's going to become all this. And then down here, these are negative outputs, right? So if you flip them, they're still going to be negative. So to be clear, I use that sine wave to see what the cosecant function looks like. I'm going to go ahead, and hopefully it's easy. I'm going to take away that sine wave because I want you to realize that graph right there is the cosecant wave, or not wave, function. So again, the cosecant function is the reciprocal of sine, and that is how we came up with this graph.